Okay, this is Mock Exam Review 2016-20. We're on question number 26 and 27. This covers the last chapter of the textbook for the course, and it talks about bipolar junction transistor. In order to give us a reference point, I would like to draw the material diagram for a bipolar junction transistor, the NPN type, which is what we studied. Okay. All right. So it says the DC current gain of a BJT amplifier indicates the ratio between. Well, this is one of the characteristics of a bipolar junction transistor. Okay. This N is represented as the collector. This P is represented as the base. And this second N is represented as the emitter. Now, we normally use this symbol to represent the three terminals of the transistor: the collector, the base, and the emitter. And we say that the collector current that goes into this terminal creates, or not creates, but composes of two currents, a base current and an emitter current. So we say the collector current plus the base current will combine together and give you the emitter current. Okay. And there is a relationship between the base current and the collector current. So the answer is there is a relationship between the base current and the collector current, and we call that beta, or beta DC. And that is IC divided by IB is called the current gain, or the DC current gain for the transistor. The word ratio means one number over another number. So in this example, it will be collector divided by the base. It seems like I have answered question number 27 by drawing the diagram for you. The three terminals of a bipolar junction transistor are called. Now, you may get confused and call it NPN, but that's not what the terminals are called. That's the material that creates the bipolar transistor. The actual terminal names is base, emitter, collector. So be careful with this question. Thank you. I think I have time enough to go to the next video, so I'll go to the next video directly. All right, this is question number 28 and 29, talking once again about the BJT transistor. Okay. The operation of a BJT transistor depends on how you apply the voltages at the three terminals. So if you apply a voltage, if you force a voltage between the P and the N, then that will be a forward bias. And you can also force a voltage between the N top, which is the collector, and the N at the bottom, which is the emitter. But you still have a terminal over here, so there's actually two voltages you have to consider. The voltage from N to P, and then the voltage from P to N. All right. There are three regions that you can operate a transistor in. It's called the active region, the saturation region, and the cutoff region. Okay? And if you want to operate the BJT as a switch, you must use these two regions, saturation and cutoff. Saturation is acting like a switch that has been closed, and the cutoff acts like a switch that is open. So in the saturation region, the current will flow straight through the transistor with very little voltage drop from the beginning to the end. But in the cutoff region, the voltage from here will directly be applied across here, and there will be very little current flowing through, which means it acts like an open circuit. So those are the two regions for using the transistor as a switch. Final question. There are three different classes of transistors, A, B, and AB. And we've only talked about one or two of them. The most common class is the A class. This is where we set up the transistor to operate as an amplifier. So the answer to question number 29 is when the transistor is set up in the active region, which is class A, we say the BJT is operating as a small signal amplifier. Thank you.